Welcome. All right, so now we're going to prove some quadrilaterals are parallelograms, or maybe we're going to prove these are not parallelograms. So decide whether each piece of given information alone is sufficient to prove quadrilateral ABCD is a parallelogram. And I cleared out some space here, so now it's not so crowded. So we'll put number 1 here. And I think this one's in your notes. E is the midpoint of AC and BD. Now these ones are a little trickier because these are almost like proof, some of them. Right? And this first one is a good example of that. Right? So I'm going to actually write this as a proof because it will be easier to keep track of our information. Right? So E is the midpoint of AC and BD, and that was given to us. Now we know a midpoint divides a segment in half. So if it's the midpoint of AC, that means it divides AC in half, and that means that AE is congruent to EC. Right? So we can write that. AE is congruent to, actually I'm going to write CE. Put the E's together. And E is also the midpoint of BD, which means it divides BD in half, which means BE is congruent to DE. So we can write that right in the same step. BE is congruent to DE, and that's because, I'll have to put step 2 way over here, midpoint divides a segment in half. Or you can say midpoint bisects a segment. Right? Is that enough information? Yes, it is. So ABCD is a, we can either draw the little symbol or we could even abbreviate, put p-grams, another way to abbreviate parallelogram. I think I'll just write it out because I do have enough space on this line here. Is a parallelogram. Which reason applies? We have a quadrilateral, I'll abbreviate quad, with both pairs of diagonals bisected. Right? And there it is. That is definitely a parallelogram, and we have proved it. All right, let's go to number 2. I'll have to decide where that number 3 is going to go. It all depends on how much space number 2 takes up. All right, so number 2, we're given that ABC, and I'll just kind of mark that there. That's that whole angle, plus BCD. BCD adds up to 180 degrees. And, well, that's not enough information, right? So this one is, we can't prove it's a parallelogram because that's not enough information. All right, so to prove ABCD is a parallelogram, either, so we need 2 pairs, right? So either angle BCD, which is the one we have here, plus angle DAB, right? So we have both, or excuse me, CAD, so we would need this one too, right? So angle BCD plus angle CDA equals 180. Or we can use this one and this one. Right? And then that would still, so we can have angle B be the one that has both its consecutive angles, or we can have angle C be the one that has both its consecutive angles supplementary. So, or angle CBD, ABC, they called it ABC, I'll be consistent. ABC plus angle DAB equals 180, and then it would be both pairs, or excuse me, one angle is supplementary to both consecutive angles. And let's make sure we say it's a quadrilateral, right? If it was, had five sides, it certainly wouldn't be a parallelogram. So that's one angle of a quad, supplementary to both consecutive angles. That would be the reason that would apply if we had two pairs of angles that were, if we had one angle that was indeed supplementary to both its consecutive angles, which we don't have. All right, so one angle of a quad supplementary to both consecutive angles. So this one was a no. All right. The other one, we proved it. And let's look at the last one here, number 3. AB is parallel to DC, so put the marking there. And BC is congruent to AD. Well, that won't work, right? So this is also a no. And we either need any one of these, right? So either both pairs of opposite sides are parallel, or both pairs of opposite sides are congruent, or one pair of opposite sides is parallel and congruent. This is the markings of an isosceles trapezoid again. All right, so any one of those things would work. All right, so either we need, so for the first reason, we would need AD parallel to CB. What is it called? AB and CD. So reason number 2, which is over here, we would need AB congruent to CD. Oops, did I put the wrong? Oh my goodness, I put CD. I put the wrong letters. I have to keep moving out of the way because my shadow was blocking it. So it was, we would either need AD and CB parallel, or excuse me, yeah. So we need the other pair of sides parallel. We already have AB and CD. We would need AD and CB. I accidentally put D instead of B. For reason number 2, I have to keep moving out of the way here, we would need AB congruent to CD. And for reason number 3, which is here, or one pair, I don't know what happened to the 1 there, but that's the reason number 3. So for reason number 3, we'd either need either one of these, right? So either we need one pair of sides, both parallel or congruent. So either AB has to be congruent to CD, or we need AD parallel to CB, so that we had one pair, both parallel and congruent. So any one of those things would prove this is a parallelogram, but we have none of those things, so that's not a parallelogram. All right, so we did 1, 2, and 3. Let's do 4, 5, and 6. All right, so only 1. This was the only yes. All right, and we did a little proof there. All right, and if you need more time to write notes down, just pause the tape. This one does have a lot of notes because it has a lot of proof, but this will help you get better at proofs, which is something some of you need. 4. ABC is congruent to a DC Did I write the wrong one? Right ones? A, oops, sorry. My eyes went down. I marked the wrong thing. A, B, C, oh, excuse me, is congruent to ADC. I misread that. And BAD, which is this one here, congruent to angle BCD. Right? This one will be a yes. Let's do a little proof. Right? So we'll start off, of course, with angle ABC congruent to angle ADC. And angle BAD, angle bad, congruent to angle BCD. This was given. And therefore, this is a short proof. ABCD is a parallelogram. And the reason that applies, we have both pairs of opposite angles of a quad are congruent. All right, so that is a parallelogram. How about number 5, which is going to be right over here. All right, so triangle ABE. All right, so this triangle here, I'm just going to outline it so we can see where the triangle is. Triangle ABE is congruent to triangle DCE. All right, so these two triangles are congruent. All right, so let's see if we can get some more things. It's hard. I don't even know if it's a no or a yes. All right, but let's see if we can get more things congruent because we have triangles congruent. Of course, we're going to start off with the given triangle. We have nothing else to start off with. A triangle ABE congruent to triangle DCE. I said DCE, and I decided to switch those. DCE, and that is given. Man, the V looks a little weird. Right? Well, if the triangle is congruent, corresponding parts have to be congruent. So AB would have to be congruent to DC. So let's write that. AB is congruent to CD. Let's see what else we can figure out. All right, well, all the corresponding parts, right? And actually, you know what? I don't think I need those. I think I see which parts I need. So ignore that. Because sometimes you start off with a proof. Now, if I left that part in there, it really wouldn't make much of a difference, right? It'd be okay. Now, there are a couple ways. I could try to get one pair of sides congruent and parallel, which I think I can do. Because I have some opposite angles. Right? But maybe let's do this the easiest way. All right? Let's do it the easiest way. And I'll try to make sure I don't do both of them the same. All right? So these are also corresponding sides, right? So AE, and D, and, oh, wait. AE and D. Oh, my. This is not what so I was thinking that I'm going to get this side congruent to this side. But AE does not correspond with EC. It corresponds with ED. Oh, no. All right, well, let's mark the parts that are congruent based on these triangles. Let's not even do anything more. Let's not even write anything. Let's just mark the congruent parts. Because the way the triangles are written, right, I begin to realize that not the parts that I thought were going to be congruent are not the parts that are actually congruent. All right, so AB is congruent to DC. Okay, so this may be the best way to start out. BE, which is this one here, is congruent to CE. Uh-oh. All right, well, that's not, I think, going to work out for us. All right, and then AE, 3 there, is congruent to DE. All right, well, look, are the diagonals bisected? Well, no, we're going to stop this proof. All right, this is a no. All right, both diagonals are not bisected. Matter of fact, none of the diagonals are bisected. Therefore, ABCD is not a parallelogram. So sometimes you think, oh, it's going to be a parallelogram because you think it's going to be, the triangles are going to be lined up correctly, and then they give you information that just doesn't work. All right, let's try the next one. Maybe this will be information that works. And I'm just going to mark the triangle. So we're going to start with our given. I am going to write that. A, B, triangle. Oh, I forgot that triangle part. Triangle ABE congruent to triangle CDE. And that is a given. Let's mark the parts from that. All right, AB is congruent to CD, the same as the other side. BE is congruent to DE. And AE is congruent to CE. Well, now that works out. All right, so that now that we have that, we have the sides I needed are AE is congruent to CE, and BE is congruent to DE. And this is because the triangle is congruent. So corresponding parts of congruent triangles congruent. I'm going to abbreviate that because I don't have too much space here. Corresponding parts of congruent triangles are congruent. Or as a student, I once had a student say, Kuputica. All right, so now that we know that ABCD is a parallelogram. Need a little bit more space. Oh, there we go. Is a parallelogram. And the reason that applies is the reason that did not apply in the last example. Both pairs of diagonals are bisected. All right, so here we did two of them, three of them as proofs, right? And then we had three no's. All right, so now let's go on and do a few more. All right, so properties of parallelograms. All right, so here are ways that we can determine if a quadrilateral is a parallelogram. And a little helpful hint there is at the bottom says, to show that a quadrilateral is a parallelogram, you only have to show that it satisfies one of these sets of conditions. If it's a parallelogram, it will satisfy all of them, but you don't necessarily have enough information to show all of them are true. And you don't have to show all of them are true. Just show one of them is true. Both pairs of opposite sides are parallel. One pair of opposite sides are parallel and congruent. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One angle is supplementary to both its consecutive angles, and the diagonals bisect each other. And I think that this whole diagram is in your notes already. All right, so now let's complete these. Check for understanding. We're going to complete this as a group. Determine if the quadrilateral must be a parallelogram. And we'll justify the answers. All right, so remember on the last video, we said that the angles in a quadrilateral add to 360. So that means angle A is equal to 360 minus angle B plus angle C plus angle D. Let me move this down here. All right, so angle A is equal to 360 minus, so angle B is 107, and then angle C is 73, angle D is 107. And actually, you know what? Let's use another. So we could prove both pairs of opposite angles are congruent. Let's actually use another method we haven't used very much. Notice that 73 plus 107 equals 180. And that means that angle B plus angle C equals 180. It also means that angle C plus angle D equals 180. All right, so notice without even proving what angle A is, by the way, it was 73 degrees, we can show this is a parallelogram, right? So ABCD is a parallelogram. So this one I'm going to do is a little paragraph proof with a little work above. ABCD is a parallelogram because one angle of a quad is supplementary to both consecutive angles. All right, so in other words, if we come back here and we look at our reasons, we used this one here. We used that reason there. All right. So that's how we decided to prove. We could have found the other missing angle, and then we could have used this one instead. But I'll put 2 arrows there to show you it's a different one. All right, but instead, we went with number 5. All right, let's do the next one. All right, so, and I'm going to do this one as a little paragraph, a 2-column proof. So this one over here is a very short paragraph proof. This one over here is going to be a kind of short 2-column proof. Right? So we're given that HE is congruent to FG. We're also given, actually I can just put this as one step. We're also given that angle FGE is congruent to angle GEH. Right, so that was given. Now, these are alternate interior angles. Right? That alternate interior angles part is based on position. Right? So it is between 2 lines on opposite sides of the transversal. Right? So it's based on its position. Because those angles are congruent, HE is parallel to FG. The reason, those are alternate interior angles, so we're going the other direction. This is the converse of alternate interior angles. And that actually is enough. Let me mark the information. That's enough information to show this is a parallelogram. So FG, let's start with E. EFGH. We'll be alphabetical. EF, doesn't matter what I start with as long as I go around in order. EFGH is a parallelogram. The reason that applies, one pair of opposite sides of a quad is both parallel and congruent. All right. So here on that one, we used reason number 2 here. One pair of opposite sides are both parallel and congruent. All right. So based on the information, that's the one we should go with, right? Because we're given alternate interior angles congruent, that gets a pair of sides parallel, and we're given a pair of sides congruent, right? So we end up with one pair of sides both parallel and congruent. So one of these involved a little bit more explaining, which is why I went with the 2-column proof, because then I don't have to write sentences. The first one didn't require all that much explaining because we had all the information we needed. That's why I did a paragraph proof. Right? And I think I'm going to save this one for the next video. And these ones will be we're going to do 1, 2, we're going to do the last 3 proofs, and then we're going to be looking at finding some missing measures in parallelograms. All right, thanks for watching. Bye for now.